Hey there, my name is Rob Stallman, and I'm a student in the Engineering Physics program at Santa Clara University. Over the last year, I've been developing a web application to visualize and compare nuclear waste data for several nuclear fuel cycles, which were the subject of a 2014 Department of Energy study. My application is called Fuel Cycle Plotter, or FCP, and is currently live at www.fuelcycleplotter.com. Studying the characteristics of nuclear waste streams produced by currently deployed nuclear reactors, as well as that of nuclear reactors which may come into operation in the near future, is essential for the long-term viability of nuclear power as an alternative energy source to polluting sources like coal, oil, and even natural gas. For the more than 60 years that we've been using commercial nuclear power in the United States and generating the waste that comes with that, our government has yet to build a long-term disposal facility for this highly radioactive waste. The de facto long-term management strategy has been to pass this highly complex issue on to the next generation. And although the storage mechanisms that are currently being used are absolutely safe for the time being, this waste management strategy is unsustainable for a variety of reasons. As a result, it is essential that a facility for long-term disposal is developed in the near future. I believe that the tool I built could aid in the planning for a long-term disposal facility by making it easy to make comparisons between and among nuclear fuel cycles on the basis of waste production. Additionally, FCP was designed to introduce the issue of long-term nuclear waste management to individuals who may be unfamiliar with the subject. As consumers of electricity, we are all connected to this issue in some way, which is why I believe that increasing awareness of the problem and engagement in possible solutions is essential. Through the development of FCP, I hope to contribute in this way to a cleaner and more sustainable energy future. For this video, I'd like to give a brief introduction to the kinds of analyses that can be made using FCP. The homepage of the application is a catalog of the fuel cycles that were evaluated in the DOE study. A fuel cycle includes every step in the life cycle of the nuclear fuel, from creation through a reactor and to disposal, stopping for any recycling or processing along the way. 40 fuel cycles were studied, so for each of these I've included an entry in the catalog with brief descriptions and a link to a section of the DOE report with more detailed information. A particularly important fuel cycle to understand is the current standard for commercial nuclear power generation in the United States. This fuel cycle is referred to in the DOE report as EG01. In the EG01 process, natural uranium is enriched and used to make low-enriched uranium oxide fuel, which is then irradiated in a pressurized water reactor and used to generate power. There is no recycling of nuclear materials in this fuel cycle. Everything gets sent to storage to cool and will eventually need to be sent to a long-term disposal facility. Using FCP, we can look at the long-term nuclear waste characteristics of the discharged fuel from the reactor from 5 years after it comes out of the reactor, all the way out to 10 million years, which is roughly how long a long-term disposal facility would need to safely store the waste. So notice here that the plots produced by FCP are normalized to 100 gigawatt years of electricity. For context, this is about 110% of the amount of electricity that the United States generated using nuclear power in 2020. Very roughly speaking, the radiotoxicity that you see in the plots produced by FCP are associated with the amount of nuclear waste that was generated in the US last year alone. Looking at this plot with the knowledge that the United States has been producing commercial nuclear power for over 60 years reveals how large the issue of radioactive waste disposal really is. And FCP is great for visualizing things like this, but a primary function of the tool is comparing different fuel cycles. So let's compare the fuel cycle that we're looking at right now with its potential successor. The DOE report suggested that another fuel cycle, which they refer to as EG23, would be a great alternative to EG01. You can see here that EG01, the solid line, is consistently higher than EG23, the dashed line. There are several reasons for the diminished radiotoxicity profile of the waste from EG23, but one important factor is that the discharged fuel in EG23 is processed so that uranium and plutonium can be fed back into the reactor. Comparing different fuel cycles using FCP will reveal that fuel cycles which utilize natural resources in an efficient manner are not only more sustainable, but are also safer when it comes to long-term waste management. I'll conclude by pointing out that there are many more ways to compare and evaluate nuclear waste data using FCP. We've been looking at total waste output from these fuel cycles, but you could also look at individual waste forms. We've been looking at the sum of all nuclear waste products in the waste stream, but you could also look at individual waste products using any of these options here. We've been looking at radiotoxicity, but you could also study radioactivity, waste heat, or waste composition. Finally, if you want to save the plot or download the data shown in the plot, you can use either of these buttons. This has been a very brief introduction to the online nuclear waste data analysis tool called Fuel Cycle Plotter that I've built. For more information, please check out the website at www.fuelcycleplotter.com.